we're doing chemistry. I know you thought it was math, didn't you? So anyways, today we're going to be talking about hydrocarbons. As you could probably, maybe, possibly, slightly tell by the name, hydrocarbons are organic molecules made out of hydrogen and carbon. So, anyway, today we're talking about alkanes, alkenes, and alkynes, the three common forms of hydrocarbons. So what is an alkane? Something with the formula CnH2n plus 2. Their name always ends in an A-N-E. So like, for example, methane, Cathars, which has the chemical formula CH4. Now, I'm going to be writing the hydrogen in a particularly small font. So, if I want them to stick out, I will write them in blue color. So now, to be stylish, let's put both of them in my pocket so I don't eat them. Now, we have CH. Alright. So now, that's methane. What about ethane? You probably heard of that one too. Well, that will be CH. Now, can you guess what this will be? And now you have H, and H continues forever. Now, can you guess what that is? Well, that, mi amigos, you probably already know that it will end with an ane.
Propane.
Oh, you piece of... It's propane. So, also it's not propane. So anyway, we know this is our chemical formula. But do you see a little pattern here? Well, I do, because notice how many hydrogens are connected to these carbons.
4.
And here, on Exhibition A, we have Stupid Matt Stupido. Anyway, there are 1, 2, 3, 4 hydrogens attached to the end of a branch. You might say, oh, there are 4 in methane, but that's because there is no end of a chain here. There are also 3 attached here, but you see this carbon in the middle of propane? That only has 2 hydrogens attached because it's in the middle of a chain. So let's write our patterns down. So we know that if a carbon is at the end of a branch, it will have 3 hydrogens attached to it. All right, that's good. If a carbon is not a branch, you could just say a chain. If a carbon is in the middle of a chain, it will have 2 hydrogens attached to it. Now the thing is, you might be saying, what is met? Oh wait, I probably shouldn't say met alone considering the implications of it. So, you can actually find that out in reference table Q, where they provide all of the organic prefixes. But I am your table Q now, because 1 here is methane, 2 here is ethane, 3 propane, 4 butane, and 5 onwards is the regular prefixes that you might expect. and usually you won't see anything past hex, but sometimes you might see octane. You'll definitely not see nonane or decane in any normal problems though. So here are our organic prefixes. Now the thing is, branch. Now usually when you have a tree, you have lots of branch. Well, same way for a lot of alkanes. Have you heard of isomers? Isomers are like allotropes. Have you heard of allotropes? Well, if you haven't, it's basically when you rearrange a molecule so it has different properties. So isomers are rearrangements of atoms that have different properties. So, some isomers have branches like trees. So, these branches can be methane, ethane. Okay, we're going to get into that, all right? So, rearrangements of atoms that have different properties, and CH4 does not have any isomers, but and neither does ethane, but propane has 2 isomers, I believe. Butane has 2 as well, but something like octane has somewhere close to 30, so they grow exponentially. So now, what are these branches? Well, let's say that you have, something like this. So, C, H, and I'm just going to draw all the other hydrogen bonds. Oh yeah, and I forgot. I'm gonna add one additional rule. Stupid found! That's not butane, idiot, Mac idiot.
Methane.
Methane.
This is actually
Propane.
2 propane.
I told you.
No, you said methane, ethane, propane, butane. Sound like you're dying, man. Stop having a seizure. So, the thing is, you actually don't need this number. Why? Well, if I put it any other way, this would actually be butane. Why? Well, let's say that you try to connect as many of these carbons as you can without picking up your pencil. 1, 2, 3. You can't do the 4th one without tracing over your lines. So that means that the largest chain in a row is 3. Bends don't count. So that's why it's prop. However, let's say I move this carbon over here, then I could connect all of them, which would make it butane. So you only need a number when you want to. You only need a number when you need to specify the location of the branch. The fact that this is propane alone specifies where the branch is. And any other place, and it would be butane. So is this wrong? No. Well, what is this 2 even for? Well, where is the branch? This is carbon number 1, this is carbon number 2, this is carbon number 3. Oops, the branch is connected to carbon number 2. So that's where the 2 comes from. So now, carbons attached to one branch has 1 hydrogen attached. And carbon attached to 2 branches has no hydrogen. attached. Alright. So those are alkanes. Now, let's move on to alkenes. Alkenes are CnH2n. So, oh wait, I forgot to mention something. These things are saturated. What does that mean? Well, they have a pretty low melting point and a pretty high boiling point. It gets higher as the molecular mass gets higher. It is not reactive because it's saturated. It only has single bonds. So, what about alkenes? Well, they contain double bonds. So, for example, let's say we have the alkene over here included in question number 2. Let me draw that up right now. H, 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 H. And then we've got the C, C. And notice that there's a double bond, meaning 4 electrons are being shared right between these two C's. That is the key identifier of an alkene. So, this is like the ID card or the social security number of an alkene. I mean, you probably shouldn't try finding out the social security numbers of anyone in real life, or you may get things that I should not say on camera. So, anyways, now, what are these alkenes? Well, these alkenes have their own rules, but they have the suffix "ene," of course, and they follow the organic prefixes. So, for example, this one right over here would be 1, 2, 3 propene. But realize that there are 3 carbons here, of course. But where is the double bond located? Between the first and the second carbon. So, that means you have 1 propene. Now, you might be asking, so Barney, what if I count this way instead? 1, 2, 3. Well, we use the shortest chain of numbers because 3 propene would just be the same as 1 propene but rotated. So that means that this is simply just 1 propene. So, now that it means that these alkenes actually have, okay, so let's see what we know so far. We know that alkenes have double bonds, so that means they're unsaturated, and they are more reactive as a result. So now, their naming rules go a little something like this. Find the carbon where the double bond is located. You may get different carbons depending on which way you count. So use the smallest one. Use the smallest chain. Which way you count. Start with smallest. Oh yeah, and did I forget to mention, you also if you have this carbon chain, you're going to name it after the largest carbon chain. So, you count and start with the smallest, yada yada. So, now, this has so this is really all of the rules for alkenes. Let me just make this extra section here. Okay, alkynes. So alkynes have the chemical formula C2H2N minus 2. And what is that? Well, that means it has triple bonds. So it's unsaturated as well and very reactive. Yada yada yada. This is an alkyne because it has a triple bond, ends in YNE, and it has the same rules as an alkene, where you just have to find the carbon where the triple bond is located. Now for this branches. So, Mr. Stupido, can you tell me what branches are?
It has to do with the tree.
Are you agreeing, Mr. Smarto? Man.
Yeah, no, it's the connections between the molecules.
Man. That's even a stupider answer. He is more correct analogy-wise. Because... oh yeah, sorry, I forgot. I was looking at the wrong attendance name. You're both stupido, sorry. So anyway, branches are, let's say you have C, and you know what? I'm just going to draw these. I'm not going through the effort of drawing all of the hydrogens. So then you have C, and the thing is, you have this branch right over here. So this is what a branch looks like. It diverts off of the main carbon chain. So this branch only has one carbon. So the prefix would be met, and it always ends in yol. So metal, or ethyl, or butyl, or propyl. So then you put this methyl, in this case, into the latter half of the name of a molecule. And in this case, the largest carbon chain is 3, so it would be prop. It's an alkane because there are no double or triple bonds. And the branch is located in number 2, but we don't need to write that because if it was located anywhere else, it would be a butane. Hoo-ha! So, now let's get on to less personas. Oh God, there are 8 of these. So, number 1. Let's name this. So, this is 3 in a row, no branches. So, that means there is no latter half. But what is 3? Well, it says prop over here. So, it would be prop, and it's an alkene. So, ane. This, as we just covered over here, is actually an alkene. You might want to cheat, so go back in time to where I wrote this down in the alkene section and cheat like that. And the double bond is located at carbon number unos. And if it was located at carbon, so now we have 1, 2, 3, propene. 1 propene. Okay. This is a alkyne, as evidenced by this triple bond over here. Ein, for very hard to pronounce. Ein, and then you have 1, 2, 3 in a row. So you have propine. Now this one is an absolute monstrosity, mi amigos. This is what we call giantos. So there is a maximum chain of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yep. It's 1, 2, 3, 4, 5. So that means it's a pent. And we know it's an alkane. And let's say that we just use the straight branch, which goes like this way. So here is going to be our straight branch, or our straight carbon chain. So don't be afraid to circle the structural diagrams. So now you have 2 branches. Both of them contain 2 carbons, which would make it et. And then they always end in yo. And finally, where are the branches located? They're located on number 3, but to be fair, if it was on located on carbon number 2 or carbon number 4, it would be a hexane. And if it was located on carbon number 1 or carbon number 5, it would be a septane. So that's why I'm just going to leave that number. No numbers for now, mi amigos. However, since there are 2 ethyls, we're going to indicate that with di. So this is diethylpentane. Okay, 5. Now this is what we call a cadet structural formula. It's basically a mixture, a hybrid between a condensed structural formula, which I'm going to teach in another lesson, and the structural formula, which you should already know. If you don't, go back to the start of chemistry class. So that means that there are 3 hydrogens, 1, 2, 3, on the left side of this carbon. There are 3 on the right side here. There is 1 up here, and there are 3 down here. So what will we call this? Well, there's a carbon chain of 3 and a branch of 1 on the bottom. So this is clearly an ane because they're an alkane because there are no double bonds. So an ane. We don't have to include the number because if we move this branch anywhere else, this would become a butane. So we are just going to call this one propane. Alright, 6. Now we're going to have to draw 3-ethylpentane. So, pentane means there are 5 lined up in 1 row. 3 means that there is an ethyl branch over here. So, ethyl means 1, 2. And then you have the hydrogens, which I'm just going to represent with these blue markings. Those are the hydrogen bonds. So that's 3 represented by this branch being on the 3rd carbon. Ethyl represented by there being 2 carbon. Pentane because there were 5 lined up in 1 row. Alright, 7. Now, this is the exact same type of formula as that. So, there are 1, 2, 3, 4, 5, 6, 7 and lined up in 1 row. There you might say 1, 2, 3, 4, 5, 6, but that's a shorter chain. And we are looking for the longest chain possible. So that makes it hept. And this is an alkane. Heptane. And this is on carbon number 1, 2, 3, 4. And it is actually important to make that distinction this time. Since if I moved it over here to number 3, then that would still be a heptane. So that means it's important to make this distinction because 3-heptane would be a different molecule. Now this is actually an ethyl branch because there are 2 carbons in it. So ethyl, 4-ethylheptane. And finally, for the end of this behemoth lesson. 8. 2-methyl 3-ethyl heptane. Heptane. There are 8 carbons in one row. 2, 3, 4, 5, 6, 7. Oh yeah, that's 7. Like heptagon. So now we have to make one methyl branch on number 2 and another ethyl branch on number 3. So number 2 would be over here. So a methyl branch. So methyl means it's going to be one singular carbon. 1, 2, 3. And let's just mark these ends up because I don't want to have to do it after. And then we have 3-ethyl. So that means it's a branch of 2 carbons on number 3, right over here. And that's 2-methyl 3-ethyl heptane. So that's it